Hi Calculus, we are going to practice inverse trig derivatives. So for number one, this is just two separate terms, 9 secant of x plus 12 cotangent of x. These are just single trig functions. There's no composite functions. So you just, for the first term, you bring the 9 along. The derivative of the secant is secant x tangent of x. And that's the derivative of the first term. Second term, that 12 comes along, and the derivative of the cotangent is negative cosecant squared. So I'm going to put the cosecant squared of x right here, and I'm going to change this positive to a negative. And that's as far as you can go. Nothing to simplify. And then your rule, we just used the trig derivatives. There wasn't a specific derivative rule. For b, there is more than one function. You have 2x and you have the cosecant, all right? And you can only see the letter x once. So that is a composite function, and that needs the chain rule. Our outer function is cosecant, and our inner function is 2x. Cosecant is the outer function because it's doing something to 2x. We're taking the cosecant of 2x. So the first step in the chain rule tells us to take the derivative of the outer. The derivative of the cosecant is negative cosecant cotangent. So you need two blank set of parentheses for where the x's are. You never put in an x when you take the derivative of the outer. Second step, we take that inner function and we plug it in both places. So this needs to be 2x here and 2x here. So that is the second step, the inner function as is, and again, both places. All right, the final step in the chain rule is we multiply everything by the derivative of the inner. The derivative of 2x using the power rule is 2. So that is the derivative of the inner. All right, and your last step is to simplify it and get the coefficient out front, get that 2 out front. So it's going to be negative 2 cosecant of 2x cotangent of 2x. And that is your final best full credit answer right here. Number 2, what rule should we start with? Well, your hint, of course, is that you see the letter x twice. So that is two separate functions multiplied together. Your first function is the sine of x, and your second function is secant squared of x. And that needs the product rule, 1d2 plus 2d1. So we start off with the first function as is, the sine of x, and now we need the derivative of the second, d2. When we take the derivative of the second function, I would rewrite this, all right, and put that exponent outside. Secant squared of x is the same as the secant of x all squared. And that tells you, hey, that is a chain rule also. So we have a chain within our chain. So for that one, the outer function is going to be something squared, and the inner function will be secant. So we do the chain rule right here for d2. So the derivative of the outer is 2 times something to the first. The inner as is secant of x, and the derivative of the inner is secant x tangent x. All right, so that whole thing is d2. All right, we come back with the second function as is, so secant squared of x, and then we need the derivative of the first. The derivative of the sine of x, that's a single trig function. That is just our derivative flashcards, cosine of x. So there is the product rule, and that is the calculus. Now we're going to clean up each term. All right, right here we have two secants. So we're going to put the 2 out front. We have secant squared of x, and we also have a tangent of x, and then don't forget that sine of x up there. So clean up each term. All right, nothing to clean up on that second term, just bring it along. Secant squared of x, cosine of x. All right, so you want to think of this as one big binomial. You got this term plus this term, and now we want to factor. What is common to each of those terms? Well, they each have a secant squared, so we can factor out secant squared. Alrighty, so it's going to look like this. We put the secant squared out front, and we rewrite that binomial. When you pull out common factors, you're just dividing. So if I divide this term by this term, I'm left with 2, and there is a tangent there, and there is a sine there. Oops, I need a little bit more room. All right, and then when I divide this term by my common factors, the secant squares cross out, and I'm left with a cosine of x. So that is your final best full credit factored answer. Number 3, again, recognize that you have the letter x twice. So that tells you that you are multiplying two separate functions together. That is always a product rule, 1d2 plus 2d1. So we start off with the first function as is, the tangent of x, and then we need the derivative of the second. This is a single trig function, so that's your derivative flashcards. The derivative of the secant is secant of x times the tangent of x. There's always a plus sign in the middle of your product rule. Now you come back with the second function as is, the secant of x, and now we need the derivative of the first, and the derivative of the tangent is secant squared of x. All right, now let's clean up each term. Right here, you can multiply the two tangents together, and that gives you tangent squared of x times the secant of x. All right, if we combine that, secant of x times secant squared of x is secant cubed of x. All right, and now we are ready to factor. Remember, think of that as one big binomial. This term plus this term. Well, what's common to each side? Hey, they each have at least one secant. You pull out the smallest power of what you have, and that's a 1. All right, so we put that common factor out front, secant of x, and then we divide each term by that. If I divide this term by this, I'm left with tangent squared. And then finally, if I divide this term, secant cubed of x, by secant of x, I'm left with secant squared of x. And that's as far as you need to go. Number 4, again, we are multiplying two separate functions together. So that is a product rule. And again, your hint is you see the letter x more than once in each of those binomials. All right, this symbol right here, d dx, that just means take the derivative. So we go to work. This is our first function, and this is our second function. So the first function as is 2x to the fourth minus 4x to the negative 1. Now we come back with the derivative of the second. This is a single trig function, so the derivative of secant of x is secant of x times the tangent of x. All right, then we have plus. We come back with the second function as is, secant of x, and now we need the derivative of the first function. And this is just a power rule. That is two separate polynomial terms. So the derivative of 2x to the fourth is 8x to the third. And then when we use the power rule here, negative 1 times negative 4 gives me positive 4, and then that would be x to the negative 2. And it says do not simplify. Yippee! So we're done. Number 5, again, key in on the fact that there are two x's. You see the letter x twice. That is two separate functions multiplied together. That is, again, a product rule. All right, so 1 as is just x. For d2, the derivative of the tangent is secant squared of x, derivative flashcards. Then we keep going. The second function as is the tangent of x. And for the derivative of the first, the derivative of this function here, that's just a power rule. The derivative of x is 1. All right, and there's really nothing to simplify there. All right, I mean, we can clean it up. We can rewrite it. You could rewrite it as, hey, x secant squared of x plus the tangent of x. All right, there you go. Easy. Number 6, this is a fraction. So that is the quotient rule. There's nothing we can do to simplify that algebraically to avoid the quotient rule. So low d high minus high d low all over low squared. You start with low. All right, so low as is x. The derivative of the high function, hey, that's a single trig function. The derivative of the secant is secant x times the tangent of x. Then it is minus the high function as is, secant of x. And for d low, hey, the derivative of our denominator x is 1. So there's our numerator. On the bottom of your quotient rule is always the low function squared, x squared. All right, let's see, what can we factor out of that numerator? Let's try to factor the numerator. What's common to each side? Well, I see oops, that's not my highlighter. I see a secant of x on each side of that numerator. Okay, so it's going to look like this. You're going to put the secant of x out front, and you're going to rewrite that numerator. We're going to leave the denominator alone. So if I divide this first term in my numerator by my common factor, I just have x tangent of x left. All right? And then if I divide this second term in my numerator by my common factor, I'm left with just 1. Alrighty, and that is as far as you need to go. Number 7 is also a quotient rule. That is a fraction, and there's no way we can simplify it. So, q prime of x. We start with low. The denominator always starts with low, as is 1 minus the tangent of x. Alright, for d high, we have to take the derivative of each term. So the derivative of this 1 is a 0. And then the derivative of the tangent is secant squared of x. Then it's minus. We come back with the high function as is. Oops, that was d high. Forgot the I. So high as is 1 plus the tangent of x. And for d low, that is also taking the derivative of each term. The derivative of 1 is 0. And then the derivative of the tangent of x is, again, secant squared of x. And it is all over our denominator 1 minus the tangent of x. Don't forget to square it. So there is the quotient rule. Now, to simplify this, I'm going to break this down for you right here. This first term, okay, this 0 is going to go away, but I'm going to rewrite this. I'm going to put this first, and it's going to look like this. Secant squared of x times that binomial, 1 minus the tangent of x. Why do I write it that way? Because then you can easily see the next step is going to be to distribute. Okay, now the next one. For this term right here, I'm going to put this term in front, just like I did over here. So it's going to look like this. Negative secant squared of x, and then times the binomial, 1 plus the tangent of x. Alright, so I'm just cleaning up each side, because then I can recognize what I have to do next. Right here, I have to distribute. So this is going to become secant squared of x. That's going to become minus secant squared of x, tangent of x. Alright, now right here, I have to simplify this. A negative and a negative is a positive. Alright, and now I distribute here. That gives me a positive secant squared of x, and that gives me a positive secant squared of x times the tangent of x. Alright, so that is the hardest part, but it really helps to rewrite it again. Put that in front, then distribute, simplify, positive, and then distribute. Alright, now you can see, let me bring the denominator down. Can't forget our denominator. But now you can see in the numerator, a couple things are going to cancel out. Right here we have a negative secant squared tangent of x, and here we have a positive secant squared tangent of x. Those go away. And then we have like terms right here. 1 secant squared of x, and then we have another secant squared of x. So our final numerator is just 2 secant squared of x. And on the bottom, 1 minus the tangent of x, all squared. And there you go. That was a tricky one algebraically, but just break it down step by step. Number 8, again, you've got 2 x's. So you're multiplying 2 separate functions together. That is our product rule. 1d2 plus 2d1. All right, J prime. First function is e to the x. Okay, for D2, that's a single trig function, and we go to our flashcards. The derivative of the cosecant is negative cosecant of x, cotangent of x. There's always a plus sign in the middle of the product rule. We come back with the second function as is, so that is cosecant of x. And then we need the derivative of the first function, and that's itself. The derivative of e to the x is e to the x. So there's 1d2 plus 2d1. So we can factor this thing because each side has a cosecant of x right here, and each side also has an e to the x. All right, so now I can factor my numerator. Okay, so I'm going to put my common factors out front. E to the x and cosecant of x. All right, then I'm going to divide this first term by my common factors, and I'm left with negative cotangent of x. And when I divide this term by my common factors, I'm just left with 1. They both cancel out. And there's your answer. Okay, you guys may skip number 9 for now during distance learning. To find the equation of the tangent line, we need to find the slope, the derivative, and we have not learned how to use that on our calculator yet. So we'll get to it. Thanks, calculus.